In today's class, obviously, we're going to continue on where we left it off in our previous class, which was transformations. And if I remember correctly, in our previous class, we did simple transformations regarding what if something multiplies to your graph, what sort of movement is going to take place, and what sort of movement is going to take place if something multiplies with only x inside your equation. And what sort of changes there could be. And we saw stuff using, we saw horizontal and vertical uh, squeezes and stretches, as well as we saw movement along the y-axis. Now, we're going to see movement along the x-axis. So let me just copy this right down. So keeping um, the same equation with what we were doing in our previous class, which was that, considering f of x is a quadratic equation, and this is the graph of y is equal to f of x, what happens when something adds on to, first of all, it was addition or subtraction to the entire equation to the outside. And now what if something is, exclusive to x? And by exclusive to x, what I mean by is that what if something adds or subtracts inside the bracket? Like it says f of x plus minus a. Clear? Whenever this is going to be the case, you're going to have movement along the x-axis. So you're going to have movement along the x-axis. What is that movement going to be now? Now we need to identify this as well. Now, again, two possibilities could happen. Like we saw above as well, you could either have, something add on to x, like positive a, which could resemble, any movement, or you could have inversely movement in the, something could subtract from x, or you could have negative a. Whenever something is being added or subtracted inside the bracket or inside the equation with only x, and if it's adding to x, what's going to happen is that you're going to move in the negative direction. Move in the negative x-axis direction. X-axis direction in terms of a. And by in terms of a, I mean is uh, how much do you need to move? That can only be understood with what you may call the magnitude of a. So whatever the magnitude of a is going to be, that is going to be the magnitude of your movement as well. Now, you guys can clearly see that when something was adding or subtracting to the entire equation, we saw that when it was adding, we saw movement in the positive y direction, and if when it was subtracting, we saw movement in the negative y direction. Over here, it's going to be the opposite. Whenever something happens to x inside the bracket, always, it's going to be some sort of opposite or inverse movement. So if something's adding to x inside the bracket, you're going to have movement in the negative x direction. And if it's subtracting, wait, I can just copy this down. Whenever it's subtracting, you can have what you may call, I'll just change these up. in the positive x-axis direction in terms of A units. Like how much you need to move, that can will be determined by the magnitude of A. Now, how do I determine this? Let's see. So for example, if something adds on to x inside the equation, my graph is going to move leftwards or in the negative x direction, like this. And how do we know how much movement it needs to go to? That will be whatever x, what you may call the magnitude of the addition in the equation. So you're going to move like this. And whenever it's, something subtracts from inside the bracket, you're going to move to the right, like this. Right, let me remove my equation from up here. So it's going to be like this. And the magnitude of your movement is going to be determined by the magnitude of A. Clear, guys? Any issues with this? It's the same thing as we saw above. The only difference is over here, movement along the y-axis. Now it's movement along the x-axis. And it's a bit of inverse movement. Inverse movement in the sense that if it's positive A, you moved in the negative direction. If it's negative A, you move in the positive direction. Clear? Okay. Let's have a visual demonstration as well. Hmm. Okay, so uh, so this is Desmos again. I am not sponsored by the app itself. I just really like using it. So y is equal to mm, any quadratic equation I can form. So it can be x whole squared plus a, and I'll add a slider. Now, what will that do is, now this is just a perfectly simple quadratic equation. Y is equal to x squared plus a. Now, this is something which is adding to the entire equation. Like, for example, if I alter this equation, it can be x plus 2 or, x plus 5 whole square. Clear? This is adding to the entire. Now, you will notice that a is adding to the entire equation. This is what is happening over here, where y is equal to f of x plus minus a. Now, if I move a positive, you will notice that it's rising up. It's moving in the positive y-axis direction in terms of a units. How many a units are there going to be? It's going to move upwards. And if I turn a negative, you will notice that it's going downwards. So you can notice that, its entire movement. Clear? Now, making sure this is the case, now let's wipe this off and make y is equal to x plus 5 whole squared. Sorry. X plus 5 whole squared. Or let's just say x plus a whole squared, sorry. And like this. And we're going to add a slider. Now, this is something that is adding or subtracting to x square inside. It's not subtracting to the entire equation. I've written a very simplified version of the equation, but if a larger equation would have been written, even then, this would have been the point where a was just adding or subtracting with x squared alone or with x alone. So now what's going to happen? As I move to the positive, as I make a more positive, it is moving in the negative x-axis direction. It's going this way. You guys can clearly see it's moving to this side. And as I make a negative, now has become negative. It is moving in the positive direction. All right. So that is how you move from positive to negative direction. That is how it is affected when um what you may call when something is adding or subtracting to a alone, to x alone inside the equation. When I did it on the broader spectrum, when I did it to the outside, you saw movement along the y-axis. When I made sure that the um any sort of number was adding or subtracting to x alone, we saw that the movement was along the x-axis. Clear, guys? Any issues with this at all?
No, sir, no issues.
All right. Moving forward, let's see now that we're almost done with the transformations. That, for example, what's going to happen now is, again, this is y is equal to f of x. Now, what happens? We've done everything, but if you guys remember, I purposely left out when we began transformations, I purposely left out negative multiplication or negative multipliers. I purposely left it out. I told you guys if a will be greater than 1 or will be between 0 and 1. We did not do negative ones. Now we're going to do negative ones. What happens when there's a negative number with, or
You
when there's a negative
a
sign?
reflection.
Yes. Well done, Barsa. So it's going to be some sort of reflection that's going to occur. All right. Whether there's an A number over here or any number over here, whenever there's a negative sign, keep this in mind that you're going to have reflection. But reflection where? You're going to have reflection in the x-axis. Reflection in the x-axis. What does that mean? Let's see. So let me just bring this guy a bit down. So let me just write this down. Hmm. Okay, I need it right here, and then I just need to reflect it completely. Oh, that was easy. Is this clear? This is called reflection in the x-axis. What is happening? Your x-axis is being featured as the middle line. This is your x-axis. It is acting as your mirror line. Clear? So whenever there's a negative number, let's see. Let's see some sort of changes to it. So y is equal to x squared. Simple. Now notice what will happen to this. Y is equal to x squared plus 2. Okay, this is an entire equation. Now I'll write the same equation, but I'll put brackets. Y is equal to x squared plus 2. Same equation, right? But put a minus sign there. Look at the difference. The red graph is a complete reflection of the what you may call the original graph, because a negative sign is multiplying with the entire equation. When that happens with the entire equation, then you're going to have reflection in the x-axis. and your x is equal to, oh, this is a y-axis, sorry, y is equal to 0, this line which I have just featured, the blue line in the middle, that is acting as your mirror line. Clear, guys? Now moving on, a similar reflection is going to be, um, let's just take this one. Now what happens if something is subtracting with x alone? Y is equal to f of minus x. What if that happens? Obviously, the inverse of it is going to happen. What is the inverse now going to happen? Reflection in the y-axis. Now, for that, I need to actually, shift my graph a bit over here in order to show the reflection. So this is going to be reflection in the y-axis. How am I going to show that? Is I think this looks like reflection, yeah. All right. And now this time around, your mirror line is your y-axis. Clear, guys? Is there anyone who doesn't understand this? Let me know. How will I feature this? Let's see. Y, oh, y is equal to x squared plus 2, right? That was the, but this time around I'm going to do minus. Oh, it's still multiplying with that. Wait, need to put more brackets in. This was my original equation, right? Now something is just multiply. It's not showing how I wanted to show. Mm. Y is equal to, okay, wait, let me alter the equation a bit. I'll knock off these guys first. Okay, and square it. So this is my equation. And what if now I have y is equal to negative x plus 2 whole squared. So you guys can clearly see that the movement has been, the inverse movement has happened. But one thing that you need to understand is that whatever my, it's just simply a reflection. And it's reflection where? It's reflection in the y-axis. All right, the black line that I've drawn. Clear, guys? Is there any
Yeah.
questions regarding this? Anything that anyone doesn't get? All right, hopefully this is clear. And if there's anything that you guys don't get, let me know. Okay, write this down. With this, we're more or less done with the concept part of transformations. Kindly please write it down, all of it, and let me know when you're done, guys.
So what happens if the f is also negative and